The vorticella telotroch. A sessile individual vorticella attached to a fixed position in its environment can undergo morphologic metamorphosis into a potentially free-swimming motile organism and disconnect itself from its stalk and migrate to a new location, possibly a more hospitable environment. The free-swimming migratory stage is known as a telotroch. Reproduction can occur via budding, as shown in the accompanying video below. Sometimes, as shown in a prior program and summarized on the next screen, the parent cell undergoes longitudinal fission and the daughter cell becomes the developing telotroch. In any case, the daughter cell is released and becomes a telotroch or swarmer, swimming freely until it finds suitable substrate on which to attach its nascent stalk and grow into a mature sessile adult. The illustrated steps include binary fission, elongation of the forming telotroch, development of the basal ciliary trochal ring, detachment of the free-swimming larva, and eventual resettlement of the larva as a new solitary organism. The first three steps in this sequence have been discussed in a previous program. The subject of this program will be the last two, the larva and the resettlement of the maturing larva, which becomes a new young vorticella adult. There are a number of photomicrographs of the telotroch of vorticella to be found on the internet. The free-swimming telotroch undergoes extensive morphologic change from a semi-rectangular outline to the typical bell-shaped outline of the mature vorticella cell body within a period of a little more than 1 or 2 hours, hence the remarkably varied appearance in the photomicrographs. Note the very long, thin, almost redundant stalk. It is myonematous and contracts quickly into a coil, somewhat flattened into a zigzag pattern by cover glass pressure. Note the identifying coarse cilia at the base of the organism's body, the location of the trochal ring of the telotroch. The wide globular telotroch in the center, which resembles the overlapping photomicrograph on the viewer's lower left, is about to break away from its long, fragile stalk. The narrower telotroch, which resembles the other three corner drawings, is already swimming freely. This telotroch is also swimming freely. Note that it contracts periodically and that its motion is fundamentally dependent upon its basal ciliary ring. Contractility in vorticella is not limited to the adult stalk, but is also a regular feature of the body of the telotroch. This higher magnification view of a telotroch shows its coarse ciliary basal ring, its annular pellicle markings, its buccal cavity and cytostome, as well as a number of vacuoles. Note that contrary to the notion that the telotroch cytostome is closed, the cytostome periodically opens to discharge solid material. As the telotroch matures, it develops the typical inverted bell shape of the adult vorticella, with a cytostome which has active ciliary membranes under development. Simultaneously, it develops a gradually lengthening stalk, while the basal cilia undergo absorption. Note that as the cytostomal cilia increase in size, number, and activity, they set up waves of current which direct fluid and particles into the cytostome. These activities eventually become powerful enough to manifest as clockwise and counterclockwise movement of nearby particles. This young vorticella, which has all of the features of a mature adult, has developed its contractile stalk and lacks basal cilia.